my first Girl Geek event. So excited also just to hear from other Planeteers because sadly it's a large enough company that you don't automatically know everyone. And so I love hearing everyone else's stories as well. All right, so I will present. Hopefully everyone can see that okay. All right, so as I mentioned, my name is Deanna Farago, and my team and I operate a fleet of satellites that are currently imaging the entire planet every day. And traditionally, satellite operations can be very time and resource intensive. For example, in order to operate one spacecraft, you could have a room full of engineers around the clock, 24/7 monitoring telemetry and contacts and just system performance. And our satellites operate in a different paradigm and risk posture. So this has allowed us to be able to automate a lot of the operations. Even before COVID, we could operate essentially anywhere as long as we had a good internet connection in our laptop. So before I describe what that looks like, it's important to understand what the mission is and the scale of our operations. So our company's mission one is to image the entire planet every day. And you need a lot of satellites in order to do that. And so we actually, in addition to operating satellites, we design, build, and test all of our satellites in-house. And this is a big advantage for us as operators because if and when we run into issues on orbit, we can work directly with the engineers that design the satellite in order to troubleshoot the problems and help come up with on-orbit mitigations, as well as design out these bugs / features in the next spacecraft iteration. And then once in space, we use just a little bit of atmosphere that we have to use something called differential drag to space out the satellites over time. And as one satellite images over a strip of land, the one right after it should image the strip of land just adjacent to it. And this essentially creates a line scanner. So what you're seeing here is a 24-hour snapshot of what the imaging strips could look like that the satellites are capturing. And so we have a distributed team operating our satellites. We have 4 people in San Francisco, 1 person in Toronto, and a team of 4 in Berlin. And we send tasks to the ground stations, which then send the schedules up to the satellites. And just a fun fact for this group that at Planet, we have 3 satellite operations teams, and they're all managed by women. So the concept of operations is actually quite simple for these doves. We don't image over the ocean, we only image over the land. But basically, anytime they're over land, they just point down, take pictures. If they're over ground stations, we downlink those pictures and logs and we communicate with them. And then in the background, we'll just run maintenance activities. So, you know, essentially thinking of them as like tune-ups and checking in on like subsystems and keeping an eye on any degradation that might be happening or running experiments. And in theory, if the satellites are performing well, they should just be as easy as this man's rotisserie grill, where we just set it and forget it. We can even run custom experiments. We set up the tasks and not have to worry about it. However, things don't always go smooth. There's a lot of fires that can happen, and that's kind of how we know we'll never really be able to automate ourselves out of a job. These are just some examples of issues that we've seen on our satellites. So, you know, a satellite suddenly starts spinning up, and so we have to figure out, oh, why is it spinning up? And we need to detumble it. We noticed that the satellites have low battery bus voltage, and we need to take action before they start browning out and rebooting rapidly. We see that telemetry sensors are reading 0 value. Is this a real thing, or is the sensor just being faulty and we have to reset it? Or sometimes satellites just are unresponsive out of the blue, and we have to spend time to figure out, did something change? Did something break on the satellite? Or can we just set up some automation to keep an eye on it? And so all of these actions started out as manual. We would detect these problems, and then operators would spend time triaging it and then eventually taking action. And now our teams have automated responses to all of these so that they trigger off of just telemetry from the satellite. So as soon as a satellite, our automation sees like, oh, the gyro readings are reading up, then we know the robot just basically sends a task to respond to this so an operator doesn't actually have to. And this decreases latency in the system and gets the satellite back into production as quickly as possible. And there's always going to be unknown unknowns. And so we're constantly trying to find these new problems and automating responses to it. So what is a day in the life of an operator? Well, we work 9 to 5, and we have a checklist that we rotate among the team members. This enables our team to be able to have weekend and holiday coverage. So even though we're just working normal office hours, we want to make sure that there's always going to be satellite operators' eyes on the system every day. And for this number of satellites, we have to aggregate our data. Aggregating our data is key. So what that means is we build lots of dashboards based off of our telemetry and off of our logs from the satellite. And it allows us to be able to easily see if there's any satellites that are responding and acting out of family. And that will then trigger an operator to say, oh, this one's not behaving the same as its fellow satellites. I'm going to dig in further and try to triage it. We have weekday team stand-ups, and we're supported by amazing other teams in mission control. And those teams also have their own on-call. And so if something does break in the middle of the night that affects the whole fleet, those teams help support us. And so I wanted to show this because it's one of my favorite things that we've taken a picture of at Planet. And it's actually a series of pictures that we stitched together into a video. And we, just before a rocket launch, were able to opportunistically schedule a dove to take a series of images of a rocket delivering more doves to space. So just a real quick, cool shot. And that's shot by one of our satellites, so very cool. And then sadly, we won't be doing any missed high fives and hugs and mission control in person anytime soon, like our former coworker here, Rob Zimmerman. But we can still enjoy having first contacts and commissioning with one another virtually. And this is our, I guess, equivalent version of that from a few years ago when we were able to successfully make contact with 88 satellites right after launch. And so with that, that's all I really wanted to share. I couldn't go into too much detail, but I'm happy to answer questions. If you'd like to email me, I'm at deanna@planet.com.
We could all be stars. I said that tonight. We could all be stars. I said that tonight. We could all be stars. I said that tonight. We could all be stars.